Advanced Sorting Solutions, just a little bit about Steinert to start with. We're a German company, we're 125 years old. We're represented around the world, originally based in Cologne, Germany. We now have wholly owned subsidiaries in Australia, the US, Brazil, Japan, South Africa, joint ventures in China and the US. Very briefly, what I want to touch on today is Eeddy Currents systems, Eeddy Currents sorters, and more importantly our Unisort technology for the sorting of plastics and e-waste out of MSW or any other waste stream for that matter. Very briefly, a lot of you probably already know about Eeddy Currents, but what I would like to explain is there's an Eeddy Current and an Eeddy Current. All of Steinert's Eeddy Currents use an eccentric pole rotor system. So what that allows us to do is change or vary the trajectory of the material, therefore giving you a better, cleaner recovery of your ferrous material that's coming through your waste stream or through your e-waste stream. The other thing that it does is it lengthens the life of your Eeddy Current because it's less susceptible to ferrous contamination. One of the biggest issues with Eeddy Current systems is ferrous metal, ferrous particles getting into the rotor, getting into the magnetic system. They will very rapidly heat up and destroy your investment. So with an eccentric pole system, we mitigate that problem. So for those of you out there that are currently using Eeddy Currents, if you don't have an eccentric pole, you need to come talk to us because your investment's at risk. Now, more importantly, Unisort, recycling of plastics or separation of plastics from waste streams. Traditional systems use a point scanning. All of our competitors use a point scanning system. This is effective, it works, it has its limitations. You have moving parts, so you have wearing issues with that. And you could potentially also miss and not get the amount of data that you require to get an accurate separation, get an accurate idea of actually what you're looking at. Recently, RTT Steinert, which is a sister company, we released hyperspherical imaging or HSI technology. So this is the latest in near-infrared separation. Yeah, do it this way. There we go. Okay. This is the latest in near-infrared imagery technology. It's a very compact unit, as you can see there from the image. That's the whole machine. So there is no secondary control panels. There is nothing else. Everything is self-contained. So in your environment, let's be honest, the waste sector is a very dirty environment. So the minimising control panels, minimising cables, that sort of thing has got to be an advantage. We've moved away from the point-to-point scanning to a line scanning system. So what that means is we're scanning the entire belt the entire time, which allows us to draw a picture of the image, which allows us also to do some shape recognition so we can recognise a bottle with a PET label or, sorry, a PVC label. We get a lot more data from the single image. So we're scanning the whole width of the detection area at the same time. All particles in the scanning line are detected and identified at the same time. You can see from the pictures there the resolution. This is the standard resolution from a standard near-infrared sorter. You can see that there's some objects there, but you can't really see what they are. This is the picture that our system gives us, that the HSI technology does. So we can see exactly what the object is. So take, for example, the clear bottle in the middle. That has a paper label on it. Nobody else is going to see that as a bottle. They're going to see that as a bunch of different stuff and not identify it. Well, the HSI technology allows us to say that's actually a bottle and it's actually made of PET and it's got a paper label on it. We have a lot more information about the objects we're scanning. This allows us to identify mixed substances. In a perfect world, everything's made of the same material, it's on a single layer on the belt, and it's easily identified. In reality, that doesn't happen. That looks more like reality. You have overlapping materials, you have copolymer materials, where you have different a label of a different material on a bottle, or two plastics bonded together, two different polymers bonded together. Because of hyperspherical imaging, because we're gathering much more data about each object as it travels down the belt, we can identify the base material, not just what's on top. So that allows you to make a much more accurate decision about what you want to eject. It gives you a much cleaner product stream, gives you a higher value, and puts more money in your pocket. So scans with hyperspherical imaging, they are necessary to detect the original material. One of the other things that hyperspherical imaging has allowed us to do, which has never been able to be done before effectively, is identify black plastics. If you're currently using near-infrared technology for separating of plastic, and especially in the electronic waste sector, black plastic was always going to waste. With hyperspherical imaging, we're now able to detect that. Because we can detect it, we can see the item in free fall when it's not sitting on a black belt. Black on black doesn't work. So we can detect it in free fall when it's in flight, and we have the computing power to be able to identify it and eject it before it gets lost to the waste stream. So for example, in an electronic waste application, if you're processing computer monitors, about 70% of the plastic in computer monitors is black. Previously very, very difficult, or if not impossible, to recover through machinery. We can now do that. This technology is still developing. We'll continue to develop it. Right now, we're able to detect black plastic. We're now working on trying to detect black plastic bipolymer. That will be the next step. But being able to see black that's a huge step in the industry. A big advantage for you. Some of you have been wandering around, may have seen this machine on our stand, the Unisort Flake. The history of flake sorting really comes from the agricultural sector, sorting things like rice. Traditionally they're chute machines, so the material's falling down a chute, it's been identified and then ejected. They work and they work very well for the food industry. But with the abrasive nature of the recycling industry, they have a very short life. So we took that technology, we adapted our HSI technology to that, and we've developed the flake sorter, which uses a high-speed belt. It's available in different working woods. It has active object control, so we're controlling the object on the belt. Gives us a very high throughput with very high accuracy of ejection. Developed high-speed valves and state-of-the-art camera technology through the HSI system. So the flake sorter is really designed for a fine fraction material. It does use the hyperspherical imaging near-infrared camera for detection of plastics. We also do this in a colour sorter. So if you're in the electronics industry and you're granulating cable or copper wire, You want to remove any aluminium wire from that so you have a pure, clean copper product. This machine is able to do that and do it very accurately. For the plastics industry, the Unisort PR is able to remove the bottle from a waste stream, but in the plastics industry you need to take the cap and the label, you need that removed because that's now a contaminant. The Unisort Flake deals with that product very well also. So it's very high resolution, so the local resolution 2 millimeters for near infrared, 5 millimeters for colour. The spectral resolution is 3 nanometers for NIR. Using halogen lights on the near infrared. The reason we use halogen is it's a long-lasting, low heat generation, and LED in the colour. And again, active object control. So we're controlling the object as it's travelling down the belt. The belt's travelling at approximately 3 to 4 metres a second. Light plastics tend to float, so we're controlling that and eliminating any false ejections. You can see that, push the right button, and here the material's travelling down the belt. We're actively controlling them, forcing them down onto the belt through the detection system, and then ejecting them with a high speed, highly accurate shot of air. Advantages of the Unisort Flake: it's designed for recycling applications, not for the food industry. It is using state-of-the-art near-infrared sensor technology. Very high-speed valves, 1 millisecond cycle time. Much higher throughput than a shoot machine, so you can process more plastic more accurately and quicker, lowering your cost. We can fire it up to 1,000 objects per second. And more importantly, and probably the key issue here for everybody, 75% less over-sorting. So it's much more accurate than a shoot machine. So you get a cleaner product, so your product that you're manufacturing is a lot better.